In 3D graphics, it can be difficult to understand what is rendering in the scene, as what we see is the 3D world on a 2D screen. Based on the different settings on the camera and the objects, the scene can be rendered in different ways. To help us understand better our projects, there are different tools that provide the React Fiber and Three.js, such as helpers, leva, and stats. Helpers are components that help us visualize non-visible options. Let's start with the simplest one. Axis helper. This is a visual representation of the X, Y, and Z axis. It can help us understand our camera position and rotation. There is also the grid helper, which args are the size and the colors. Let's use green and blue. We now have a grid on our floor. It can help us positionate objects and scale them properly. But as you can see, it is using the camel case and we didn't have to import it. Instead, we can use another grid helper from Dry library, which is named grid. It comes with more options to add a fade effect and choose the size of the section and cells. Let's use section size is equal to 3, section color to purple, section thickness to 1, cell size to 1, cell color, we can use it in the Three.js color format, for example, -6f, 6f, 6f, cell thickness to 0.6, so our cell will be smaller than the sections. We can make it infinite, so we don't have to specify the width and the length, and fade distance to 50 and fade strength. We now have a nice grid that is fading on the horizon. I think it looks good and there are some use cases where you can use it in production project. Let's talk about the box helper. Currently we have a box here with box geometry, so a cube, but it is white and transparent with an opacity of 0. So that's why until now we didn't see that cube. To help us visualize that invisible object, we can use a helper. In this case, the box helper. To instantiate a helper from Three.js with React Fiber, we can use the use helper hook. Use helper. It takes a reference on the object we want to put it. Let's say ref. We need to declare our reference. So const ref is equal to use ref and assign it to the mesh here. It's a ref. Now the second parameter of use helper is the type of helper. So 3.boxHelper. Don't forget when you use Three.js to import it. And then the third parameter is the color. Let's say red. Now, even if our cube is invisible, we can see it thanks to the helper. Thanks to the use helper hook from React 3 Dry, we don't have to bother about instantiation, update, and removal. It takes care of it for us. Another way to help us inside our Three.js project is to use Leva library. It's a UI library coming with input components that help us tweak values and see the result in real time. To install it, we need to open the terminal, run yarn add and leva. Once it's done, we can restart our development server. To use leva, it's very simple. It comes with a hook named useControls. The parameter is an object with the name of the variable you want to edit. And to edit a vector3, you can directly say x, y, and z value. So it will return you an object containing the position property. So we can destructurate it doing this. And we will get our position with the x, y, and z value in real time. So on our mesh, we can say position is equal to an array of position.x, position.y, and position.z. Now we can see on the top right, we have the UI from Leva, and we can edit here with drag and drop or setting manually the position of our cube. As you can see on this screenshot of Leva, there are different input types. You can see all of them in the documentation here, but let's use some of them. Let's say we want to update the color. It will automatically detect it's a color. So we just need to put the string here. We can also define a more complex object for opacity. We just want to say it's a value of 0.5, but there are other settings that we can use. For example, the minimum value, we want it to define to 0, the maximum to 1, and the step, when we are using the slider, we will put it to 0.01. And we can also create checkboxes with booleans. So let's say transparent is true. To get access to our new properties, we can destructurate them here: color, opacity, and transparent. Now on our material, let's update the properties with the one set up with leva. Color is equal to color. Transparent is equal to the transparent variable, and opacity to the opacity one. Now we can adjust it in real time. We can change the opacity, making it transparent or not transparent at all. Change the color with this nice color picker. Let's make it purple. And we can say it's not transparent anymore, or it is. When you are happy with the values, you can just copy them, set them as the default values here. So it's the values that will be used in your project. Let's say the opacity is 0.85. And when you want to go into production mode and hide the UI here, next to the canvas, you can declare leva and set the property hidden. So it's hidden by default. Now you can see the UI anymore, but the cube is in the correct values, and you can enable leva when you need to fine-tune the values. You now know the essential of leva, but you can read the documentation to go further. Let's discover a last tool to help us debug our scene, which is the stats component. It comes from Dry. It will add on the top left corner, let's zoom on it, the frame per second. If you click on it, you can see the milliseconds that are needed to render a frame. So the lower, the better. And if you click again, you can see the megabyte of memory used. There are more advanced tools to get stats on our scene. We will see them in the optimization lesson, but it's a good starting point to start debugging your project.